Motion is all around us. So to understand motion, we need to understand the vocabulary of motion. Let's take a look. We have to start motion from somewhere. So let's put a point here. This point is called a reference point. And a reference point is simply the point from which we're going to measure all of our motion. That's pretty simple. You might want to write that down if you don't already have that. Now let's pick another point. Let's say here. Notice that there's some space between those 2 points here. Now the amount of space between the 2 points, or how far away it is, we call that distance. The measure of how far it is between 2 points. Now, distance is what we call a scalar quantity. Well, what does that mean? Scalar means that the measurement only has magnitude, which is the amount, but no directions. For example, if I were to tell you that I traveled 10 miles, what? That's not too good. If I were to tell you I traveled 10 miles, does that tell you what direction I went? No, it doesn't. It only tells you how far. If I were to tell you that I threw the ball 20 meters, does that tell you what direction I threw the ball? No, it does not. It only has amount or magnitude, and we call those types of measurements scalar. Distance is a scalar measurement. But frequently, we do need to know which direction an object is moving and maybe how far away it is. So we have a way of measuring that. We call that measurement a vector. And we illustrate a vector by drawing an arrow. You have a head or an arrowhead on one end and nothing on the other. You always start from your reference point or where you're going from, and you draw it in the direction that you're moving. So a vector, you might have been able to conclude, has both magnitude and direction. For example, we might say that this is going to the right, which might be on a map, direction east. And we might say that this has a magnitude of 12 kilometers. So the vector measurement would be 12 kilometers to the east. And that does tell us exactly where an object might be. If I said I was 10 miles north of Thornton Middle School, we could get out Google Earth and we could measure 10 miles north of Thornton Middle School, and you know exactly where I was. So let's take a little trip to illustrate this point. Again, we're going to say that this is a map. So let's say you're at home and you're going to be traveling to school, and the school's going to be over here. So which direction would you go? Well, you'd obviously go from home to the school. So you're going to be traveling in an easterly direction. So I'm just going to draw a vector here, and I'm going to say it's 4 kilometers. So far our distance traveled is 4 kilometers. The vector is 4 kilometers to the east again. So after school you decide you're going to go to the library. Which direction would you go? Well, you would go up here, and to the top of a map is always going to be north. So I'm going to draw that in. 2 kilometers north. So now our total distance has been 6 kilometers, and we traveled 4 kilometers east and 2 kilometers north. Now let's say after you go to the library that you'd like to go to the mall to do some shopping, I guess. So which direction are you going to travel? Well, this time you're going this way, and the left on a map is always in the westerly direction. So I'm going to draw that vector in there, and it just happens to be 4 kilometers. Now after you go to the mall, you're ready to go home. So you're going to go what direction? You're going to go to the south. So I'll draw that vector, and that completes our trip. Here's a question for you. What's the total distance traveled? Well, it would be 4 plus 2 is 6, plus 4 is 10, plus 2 more would be 12. So the distance traveled is 12 kilometers. Let's do one more example. Here's a reference point. And we want to talk about a new measurement called displacement. But rather than telling you what that is, I want to show you. So let's start from our reference point, and we're going to travel west. Which direction is west? That would be over here. So we're going to go to the west, and we're going to go 2 kilometers. So I draw a vector to the west, 2 kilometers. Now we're going to go north, which is which direction? Up. And let's say we go 4 kilometers to the north. Notice that when I drew this vector, I made it twice as long as this one, as it should be, because 4 kilometers is twice as long as 2 kilometers. Let's go 5 kilometers to the east. Notice that this one is about 1, 2, 2.5 times as long as this one, as it should be, because 5 is 2.5 times as long as 2. And we're going to make one more trip. We're going to go south 4 kilometers, and we're going to end. Now, the question is, what is displacement? Well, displacement is this measurement right here. Notice that the arrow is on this end, and it goes from the starting point to where we finally end up, or where we stop moving, wherever we're measuring, okay? So displacement then could be labeled as, or defined as, the distance and direction, which is a vector, from the starting point to the ending point. You've always got to go from the starting point to the finish point or the ending point. Now I have a question for you. Can we figure out how much that is? Well, I think we should be able to do that. Let me see if I can do this. If I draw an arrow from here to here, how long would you say that is? Well, it's 5 kilometers, because this is 5 kilometers and I made this arrow the same length. So if I move this arrow down here, how far is it from this point over here to this point over here? And the answer is 5 kilometers. It's 5 kilometers anywhere along here. Now, if we know this is 5 kilometers, and we know this is 2 kilometers from here to here, how long must this displacement be? Well, if you said 3 kilometers, you would have been correct. So in this case, 3 kilometers. Let's do one more example. Let's say you're a marathon runner. How long is a marathon? Well, a marathon is 26 miles. And typically in a marathon, the starting and the finish line are the same space, or the same place. So let's say you're running your race. Boom! The gun goes off. You start running. You run around town. You go down this way. You go down this way. You run around City Hall. You come down here around the school. And you finally come back and you finish your race. So the question is, what is the distance you ran? And what is your displacement? Let me draw that one more time for you. I ran around here and here and here and here and here, and I come up here and I finish the race. All right, so I told you a marathon is 26 miles. So what's the total distance run? 26 miles. That's the distance. Now, what's the displacement? Well, since we started and we finished in the same place, the measurement between those two is going to be 0 miles. Our displacement is 0 miles. Now that's kind of strange, but it is a fact. You start and you finish at the same place. Your displacement is going to be 0. Alright, so there's some of the basic vocabulary we're going to be using when we talk about motion. Let's review that very quickly. Today you learned about a reference point, and that's simply the starting point from which we're going to measure our motion. You learned about distance, and that is how far it is between two different points. You learned that distance is a scalar quantity, meaning it only has magnitude, it has no direction. You learned what a vector is. It has magnitude and direction, such as 3 miles to the south, or 4 miles to the east, or 20 kilometers north. We also talked about displacement, which is the difference between the starting point and the ending point. And we said that all of these are vocabulary words and concepts that we use when we talk about motion. So there you go. We're off to a good start talking about motion. We've got some other things to talk about, namely speed, velocity, and acceleration, but we'll do that in another video. So I hope you've enjoyed this. I hope you've learned a little bit. If you have questions, ask your teacher. If you need to go back, please rewind and play again. And until then, my friends, keep on learning.